0.7 earthquake hit off the coast of Russia.
After a magnitude 8.7 earthquake hit off the western coast of Russia, north of Japan.
The United States Geological Survey, USGS, has issued a rare and urgent red alert following the discovery of significant cracks beneath the Columbia River bed, a development that has sent shockwaves through the scientific and environmental communities. These newly detected fissures, located in a geologically sensitive region of the Pacific Northwest, represent more than just surface anomalies. They could be the earliest signals of deep tectonic disturbances unfolding beneath one of North America's most vital waterways. While the public often associates geological threats with highly active fault lines like the San Andreas or dramatic volcanic events, the Columbia River region, long thought to be relatively stable, is now drawing serious attention from geologists and federal agencies alike. Before we start, smash the like and subscribe buttons for more updates. The cracks were detected using a combination of sonar imaging, seismic reflection data, and sub-bottom profiling technologies, which together revealed a network of deep fractures cutting across the riverbed. This network was initially spotted by researchers monitoring sediment movements in the lower Columbia Basin. What they found, however, far exceeded the expected parameters of riverine geology. Rather than being the result of mere erosion or sediment shifts, the cracks appear to be structurally embedded into the bedrock itself, suggesting tectonic stress at work beneath the surface. Some of these fissures span several kilometers, and their widths vary from a few centimeters to nearly a meter in certain areas. Most alarmingly, the orientation and propagation of these cracks indicate active pressure from below, potentially from movements along long dormant faults or from magma chambers reawakening in the deeper lithosphere. This area, while not typically categorized among the high-risk zones like California or Alaska, does sit within the broader influence of the Cascadia subduction zone, a massive fault line running from northern California to British Columbia. The Columbia River Basin, though slightly inland, is still geologically tethered to this volatile tectonic environment. The cracks suggest that stress may be migrating, diffusing from the primary subduction zone and manifesting in regions previously considered geologically benign. The ramifications of such movement are staggering. If the crust beneath the Columbia River is beginning to deform, the implications extend far beyond structural geology. They touch on hydrology, ecology, infrastructure, and public safety on a potentially massive scale. One of the immediate concerns revolves around the structural integrity of the dams and hydroelectric systems that depend on the Columbia River. The river is home to several key dams such as the Bonneville, the Dalles, and John Day, which provide electricity to millions of residents and serve critical irrigation and navigation functions. If these subterranean cracks indicate increasing tectonic strain, the foundations of these colossal engineering feats could be compromised. Subsurface movement, even at millimeter scales, can lead to differential stresses that concrete and steel are not designed to withstand indefinitely. The mere presence of fissures doesn't necessarily mean catastrophe is imminent, but the fact that they are widening and doing so in such a short period is deeply troubling to those who monitor the stability of these structures. Hydrologically, the implications are equally severe. The Columbia River serves as a major freshwater artery, supporting not only human populations but also a fragile ecological web. Cracks in the riverbed can alter groundwater flow, create new aquifers, or disrupt existing ones. This can lead to unanticipated shifts in water tables, increased turbidity in the river, and potentially even contamination from subsurface materials being leached into the water. In the worst-case scenario, fissures could evolve into channels for hot gases or geothermal fluids, which would have cascading consequences for water chemistry and aquatic life. The Columbia supports salmon populations already under stress from climate change and dam construction. An increase in water temperature or chemical instability could tip the scales against their survival. What sets this red alert apart from typical geological advisories is the combination of factors converging at once: seismic irregularities, unusual heat signatures detected via thermal imaging, and now physical fissures that imply an acceleration of underground dynamics. Some researchers are now speculating whether the Columbia River Basin is experiencing a form of silent deformation, a process by which tectonic plates shift without producing major earthquakes, yet slowly strain the crust until it fails catastrophically. This has precedent. Similar patterns were observed in Japan's Tohoku region before the 2011 earthquake and tsunami. The slow buildup of tectonic stress was barely detectable until it culminated in one of the most devastating natural disasters in recent memory. Compounding the geological complexity is the presence of multiple volcanic systems in relatively close proximity to the cracked area. Mount Hood, Mount St. Helens, and Mount Adams all lie within the broader vicinity. Though none are currently erupting, any increase in regional stress could serve as a trigger for a magmatic movement. Volcanic systems are incredibly sensitive to changes in pressure, and a disturbance beneath the riverbed could potentially awaken dormant systems by altering the underground pathways through which magma travels. Seismic tomography has even revealed low-density zones interpreted as magma bodies lingering not far below the crust in parts of this region. If pressure is building and seeking new release points, these volcanoes could enter new phases of activity. The Columbia River Gorge, with its iconic basalt cliffs and dramatic landscapes, was carved by cataclysmic floods during the last ice age. Those floods were triggered by sudden glacial dam collapses, but they set a precedent for how quickly the landscape here can change. Now, with the possibility of tectonic or magmatic activity escalating, some experts are drawing uneasy comparisons. A rupture of sufficient magnitude beneath or near the river could lead to sudden landslides, flooding, or even the rerouting of entire sections of the waterway. These aren't theoretical exaggerations. The geological history of the region proves such upheavals have occurred before, and the conditions now are beginning to align in disquieting ways. Critical transportation routes also cross the Columbia River, including major interstates, railways, and bridges that connect Washington and Oregon. The I-5 and I-84 corridors depend heavily on this infrastructure to move goods and people. If the cracks extend toward any of these key points, the potential for disruption is enormous. Bridges that span the river could be particularly vulnerable. Subsurface instability could compromise pylons and anchor points, leading to structural fatigue. Engineers will need to reassess foundational loads and resilience under seismic duress. The economic impact of even partial closures of these routes would ripple across multiple states, affecting supply chains from the Pacific ports all the way to the Midwest. This discovery also poses a major challenge for urban planners and emergency management agencies. Cities like Portland, Vancouver, and Tri-Cities lie within reach of any disaster that might originate from this region. The cracks signal that risk assessments may need a fundamental rethinking. Emergency protocols tailored for wildfires or seasonal flooding may not be sufficient to handle a tectonic crisis. Evacuation routes, supply depots, and public warning systems would need to be reassessed in the light of this new, unpredictable threat. The fact that this is happening in a zone not previously flagged as high risk adds another layer of complexity, as much of the population and infrastructure may be underprepared for what could come next. Environmental scientists are also watching this situation closely. A tectonic event under the river could disrupt sediment cycles, dislodge pollutants buried for decades, and even release natural gas hydrates trapped in riverbed strata. These hydrates, when destabilized, release methane, a potent greenhouse gas, into the atmosphere. This could add an unexpected climate feedback loop to the region's environmental profile. Similarly, soil and rock displaced by underground movement could set off a domino effect in the delicate balance of ecosystems that depend on seasonal flooding and silt deposits. Even minor shifts in the physical terrain could have major implications for wetlands, bird migrations, and fish spawning cycles. The situation also has implications for tribal lands and communities that have deep historical and spiritual connections to the Columbia River. Many indigenous nations have relied on this river for millennia, not just for sustenance, but as a cornerstone of cultural identity. A disruption of this magnitude would not only threaten physical resources like fish and water, but also sacred sites and traditional practices. Tribal leaders are now pressing for inclusion in briefings and decision-making processes as the crisis evolves. They bring a long view to the river's behavior, passed down through oral histories that speak of changes and cycles modern science is only beginning to comprehend. As the USGS continues its analysis, more sophisticated sensors are being deployed across the region. Deep Earth seismometers, thermal probes, and satellite-based interferometry will help build a 3D picture of what's occurring below the surface. Already, early results show microseismic activity increasing in frequency, though not yet in intensity. This is typically a sign of stress migration, a possible harbinger of a larger quake. The challenge lies in interpreting these signs quickly enough to make meaningful decisions. With the region's population centers so close and critical infrastructure straddling the river, the window for action may be narrow. This event is forcing scientists to reconsider established models of tectonic behavior in the Pacific Northwest. It suggests that the crust here may be more segmented and dynamic than previously believed, capable of storing and transferring stress in unpredictable ways. The Columbia River, once viewed as a relatively stable geological corridor, now appears to be a potential pressure point in the broader Cascadian system. This revelation is pushing geologists to revisit past anomalies, strange tremors, unusual gas releases, unexplained electromagnetic disturbances, and recontextualize them in light of this new development. The cracks also raise unsettling questions about the interconnectedness of seemingly separate geological features. Could this be part of a chain reaction triggered by broader shifts in the Earth's mantle beneath the Pacific Plate? Could similar fractures be forming under other rivers in the West? If so, a continent-wide reassessment of seismic vulnerability may be in order. The USGS Red Alert is not simply a localized warning. It's a signal that the North American plate is perhaps entering a more volatile phase. And the Columbia River, with its strategic, ecological, and symbolic importance, is now squarely in the crosshairs. As drones scan the river for surface anomalies and submersibles chart the underwater terrain, scientists are racing against time. They must determine not only the extent of the cracking, but also the mechanisms driving it. Is it purely tectonic? Is there volcanic pressure at work? Or are both converging in a rare and dangerous conjunction? The data coming in suggests that something unprecedented is unfolding beneath the waters. And while the surface remains calm for now, the story it conceals is one of rising pressure, shifting Earth, and the possibility of profound transformation. The Columbia River has long been a source of life, power, and natural beauty, but now it is becoming something else entirely, a mirror to deeper hidden processes that shape continents and determine destinies. The Red Alert stands not just as a warning, but as a challenge to understand a planet that is always in motion, and to do so before the next crack widens into something irreversible. The cracks beneath the Columbia riverbed have not only altered the immediate scientific narrative, but have also galvanized a renewed wave of interdisciplinary collaboration among geologists, volcanologists, civil engineers, and climate scientists. This is no ordinary tectonic event. While fissures in riverbeds are not unprecedented, the specific orientation, depth, and apparent rate of development in the Columbia Basin are atypical enough to demand a reevaluation of how subsurface stress is distributed across continental interiors. Beyond the geology, the surrounding region is undergoing a profound moment of uncertainty as implications reverberate through nearly every facet of modern infrastructure and environmental stability. The initial assessments have triggered a more extensive geophysical survey, which is now extending well beyond the immediate vicinity of the riverbed. The discovery has opened up new questions about underlying crustal weaknesses, not just in the Columbia River's central flow, but along its tributaries and adjacent valleys. Sophisticated magnetotelluric surveys, techniques that map variations in the Earth's electromagnetic fields, are being implemented to detect subtle shifts in mineral conductivity deep underground. These methods can help identify the presence of fluids, magma, or fractured rock masses, all of which are essential in understanding whether these cracks are localized expressions or a part of a larger crustal system undergoing transformation. As deeper imaging becomes available, scientists are discovering unusual thermal gradients at depths that suggest convective heat is moving toward the upper crust more rapidly than previously modeled in this region. While not definitive evidence of magmatic intrusion, the presence of heat anomalies so close to a freshwater system raises significant concerns. Increased geothermal activity near a major river could lead to hydrothermal alteration of bedrock, weakening structural integrity over time. The cumulative effect of heat, stress, and water erosion could gradually transform the character of the Columbia River from a sediment-stable system to one more prone to landslides, slumps, and rapid sediment displacement. all potential triggers for flash floods or dam stress events. From a civil engineering standpoint, contingency measures are already being proposed in theoretical models. Emergency reinforcement strategies are under review for major dam foundations, especially those with deep footings extending into potentially unstable bedrock. Engineers must now model their systems not only for vertical gravitational stresses and lateral water pressure, but also for shear forces and vibrational profiles that could emanate from low-magnitude, sustained tectonic adjustments. These represent a new class of challenges, less dramatic than massive earthquakes, but capable of long-term degradation. This could mean adjustments to floodgate mechanisms, retrofitting of pressure relief tunnels, and recalibration of sensor arrays embedded in the dam bodies. The presence of these cracks is also transforming the way emergency response scenarios are structured. Standard protocols, designed around predictable seasonal flooding or earthquake drills, are being rewritten to incorporate multi-phase emergencies. A possible rupture followed by landslide, a temporary dam breach, and then downstream flooding. The multi-stage nature of this kind of threat demands a different form of public awareness, one that's not rooted in sudden impact, but in slow, accumulating change that may reach a tipping point with little notice. This is particularly difficult to communicate to the public, who are conditioned to respond to discrete emergencies with clear beginnings and endings. Beyond the technical and emergency management implications lies a growing scientific curiosity about what these cracks can reveal about deeper Earth processes. The Columbia Basin has long been considered a zone of geologic interest, not least because of its layered basalt formations from the Miocene epoch, vast lava flows that once engulfed much of the region. These rock layers preserve a kind of geologic memory, allowing modern-day researchers to trace past flows, stress points, and fracture zones. If the current cracks are exploiting ancient faults or following patterns of historical weakness, it may unlock insights into how tectonic memory influences present-day instability. In other words, Earth's past ruptures may dictate where future ones unfold. The human dimension of this discovery cannot be overlooked. Residents in riverside towns like Hood River, the Dalles, and Longview are grappling with the unease of knowing that something immense and invisible is changing beneath their feet. While officials are working to prevent public panic, there's a palpable shift in the mood among locals who've lived along the river for generations. Fishing families, recreational businesses, and agricultural operators whose livelihoods depend on the stability and predictability of the river now face a level of uncertainty they've never encountered. The psychological toll of living near an invisible threat is unique. It creates a sustained sense of vigilance that can affect mental health, economic planning, and long-term community cohesion. Insurance companies are taking notice as well. While earthquakes are often excluded from general coverage unless specified, this unique geological development has triggered a reevaluation of what counts as an act of God or a pre-existing condition in infrastructure failure. With growing speculation that these cracks could preface a larger geophysical event, underwriters are bracing for a potential rush of claims and policy adjustments. At the same time, reinsurers, those who insure the insurers, are quietly modeling worst-case scenarios that factor in dam failures, crop disruption, and even cross-border impact into Canada, given the river's far-reaching drainage network. What's perhaps most unnerving is the possibility that the cracks beneath the Columbia could be a bellwether, an early signal in a global pattern of increasing tectonic volatility. Similar observations have been made in other large river systems, such as the Yangtze, the Amazon, and the Nile, though not yet on a scale prompting emergency alerts. Climate change, while not a direct cause of tectonic movement, exerts pressure on the lithosphere by way of ice melt, sea level rise, and atmospheric loading. These changes subtly redistribute weight across Earth's surface, and there's increasing interest in the hypothesis that the Earth's crust may be entering a reactive phase to these shifting loads. If true, rivers, by virtue of being natural pressure release points, may show the earliest signs of deeper disruption. Academia is responding with a flood of new research initiatives. Grants are being issued for rapid response field studies, and universities across the West Coast are sending teams to the affected areas. Graduate students are being deployed with portable seismographs, drone-based LiDAR, and hydroacoustic sensors to capture as much data as possible before further structural changes take place. This is a rare scientific opportunity to observe the early stages of a potentially historic tectonic transition. Normally, such changes are reconstructed after the fact. Here, for once, science may get a front row seat as the Earth prepares to move. Federal and state governments are also coordinating to prepare legal and logistical frameworks for possible relocation efforts should the cracks worsen. While no evacuations have been ordered, contingency zones are being outlined in confidential briefings. These would include priority designations for hospital evacuations, school closures, and emergency sheltering. FEMA has reportedly activated its Seismic Risk Division to begin planning for a multi-sector response in case of structural collapse or flood scenarios. National Guard units may eventually be tasked with safeguarding infrastructure or even coordinating supply deliveries should transportation routes be severed. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the Columbia River bed cracks and possible eruption risks? We want to hear from you. Thank you for watching, and see you next time.